This is just intended to be a quick explanation of how to use your calculator to solve a linear trigonometric equation. So I'm going to know that this is what's happening when once I get my sine, cosine, or tangent function alone. The ratio on the other side of the equation, this guy over here, is not a ratio that we've seen from the unit circle. So it's not 0, plus or minus 1, plus or minus a half, plus or minus root 2 over 2, or plus or minus square root of 3 over 2. It's something else. It's a fraction or a decimal. So in these cases, I know that I need to go to my graphing calculator and I need to use the inverse function to undo sine in this case to solve. Some things we need to think about up front. The instructions here tell us to solve for all angles between 0 and 2 pi. So our angles have to have positive rotation, and they have to be all the angles between 0 and 2 pi. So things that we should be thinking. We know, based off of our work with ASTC, that this is an example of sine being positive. So we know that our answers have to fall, two of them, there has to be two, one in quadrant 1 and one in quadrant 2. The one here in quadrant 1, this is what we called our principal value when we were talking about inverse trig. This is the value that we'll get from our calculator. The one in quadrant 2 we are going to have to determine based off of our calculator work. So I want to solve this here. Again, I need to undo sine, so I'm going to take the inverse sine of both sides. And in this case, I'm just going to wind up with the equation theta equals sine inverse of 9 out of 20. Now, the sine inverse notation has to fall before the ratio, otherwise it doesn't make sense because this is not a multiplication. Remember, this says, this basically says what angle in this restriction has a sine or a y value of 9 over 20. So if I were to draw a quick sketch of what I'm talking about, there's going to be two answers, and I'll draw a sketch for each of them. Both of them will have y values of 9 over 20, which is actually pretty small. So I'm going to say maybe this is the first one that we're talking about, this guy here. And the second guy we're talking about has the same y value, but it's in quadrant 2. So I'm talking about this one right here. Now we should remember from our previous units and lessons that the thing that's the same on both of these is their reference angle. So I'm going to say that red angle is the reference angle. So my first one, the reference angle, will be what the calculator tells me. And in the second guy, this is going to be pi minus the reference angle for my angle of rotation. So we need to use our graphing calculator in radian mode because I want all of our answers to be in radians. So we've already switched it to radian mode. Unless you've switched it back, you should be all set. And you're just literally going to hit second sine, which is inverse sine, of 9 over 20. Your calculator should in turn give you the results, if you did it correctly, of 0.4668 radians, more or less. So that's saying that in this first drawing, this reference is 0.4668. So that's actually my first angle. Quadrant 1, the reference angle, is the same thing in the angle. Our second angle is this guy over here. So they're saying that this reference is 0.4668. So my second angle would be pi minus 0.4668, which comes out to be approximately 2.6748, which makes sense to me because I know that pi over 2 is 1.57 and pi is 3.14, and this is somewhere between those. So those are our two final results for this question. Theta is 0.4668 or pi minus 0.4668. I would do the same thing if it was an inverse cosine or an inverse tangent equation. The only difference is where the restrictions will be. So I will try one second example briefly. I'll take a look at a cosine one. This corresponds to number 10 on your packet. So if I have cosine theta equals negative 0.334, again, I'm making myself a side comment. Cosine is negative in two quadrants. It's negative where x is negative, so that would happen in quadrants 2 and quadrant 3. And this guy right here is my principal one. So I am thinking pictorially that cosine is negative over here, and cosine is also negative down here. And again, the thing that they have in common is their reference. So I'm looking for the ones that rotate from 0 to the location of the terminal side, excuse me. Again, to find these, I go to my calculator, I do theta equals inverse cosine of the ratio that was given to me, in this case, negative 0.334. And my calculator spits back to me that that answer is approximately 1.9113. So that's this angle here, 1.9113. That's one of my answers. The second answer we need to be a little bit more clever on, because 1.9113 is not the reference. So although these guys do have the same reference angles, that's not the fastest way to deal with a cosine problem. What is faster is for us to recognize that this 1.9113 in the positive direction gets traveled in the negative direction on my second graph. So this angle right here would be 1.9113 as well. So our second answer would be that it's 1.9113 short of 2 pi. And that comes out to be roughly 4.3718 radians. So those are our two answers for that one cosine question.